So element X has only one electron in the valence shell. So for element X to become like a noble gas, it is easy to remove this. Okay, remove this electron to become like a noble gas. If it does that, it's going to remove one negative charge, meaning it's going to form X plus ions, X plus 1 ions. So, okay. And on the other hand, I did not budget my space well here, but that's okay. Okay. On the other hand, element Y has 5 electrons in the valence shell. Okay. And then for it to become like a noble gas, it is easier to gain 3 electrons rather than, removing 5 electrons. If it gains 3 electrons to have an octet or 8 electrons in the valence shell, okay, 3 electrons coming in, okay, is going to have a negative 3 charge. Okay. So to neutralize one Y3 minus ion, you're going to need 3 X plus ions. Therefore, the formula should be X3Y. By the way, just a reminder, combustion means you are reacting with oxygen, okay? So in this particular reaction, you have C2H6 that is reacting with oxygen, O2. Okay, and that's going to produce carbon dioxide, CO2, plus H2O. This, let's do the balancing now. You have 2 carbons on the reactant side, so I'm going to multiply the carbon dioxide by 2, so that I can have 2 carbons on the product side as well. And we have 6 hydrogens on the reactant side, so I'm going to multiply H2O by 3. So that I can now have 6 hydrogens on the product side as well. Now oxygens, I have 2 on the reactant side, but on the product side we have 7, 4 from the carbon dioxide molecules and 3 from the H2O molecules. Therefore, I want to have 7 on the reactant side as well. So I'm going to multiply this by 7. But if I do that, I'm going to get 14 atoms, not 7, 14. So I'm going to divide that by 2. Okay, if I do that, now I have 7 oxygen atoms on the reactant side as well. Okay, now I don't want fractions in my balanced chemical equation, so I'm going to get rid of the fraction by multiplying everything by the denominator. So here's 2 canceling out. This 2 is going to become 4, and this 3 is going to become 6. So that's going to be my balanced chemical equation. All right, do we have any questions about that? Anything? Okay, now once we have that, we look at what is given and what is being asked. Okay, what is given to us is the moles of CO2. Okay, and then what they're asking is how many moles of ethane is needed. Okay, this is what is asked and this is what is given. Okay, so based on the balanced chemical equation, to get 4 CO2 molecules or CO2 moles, I need 2 moles of C2H6. So I'm going to write that. Okay, to get 4, I need 2. Okay, therefore, to get 1, I'm going to need 2 divided by 4. Meaning, I need 1/2 molecule. Half moles of C2H6 to get 1 CO2 mole. Okay, but they're asking to get 50 moles. Okay, so to get 50, then I need to multiply what I need to get 1 by 50. Therefore, I'm going to get 25. That should be my answer. Okay, one more time. To get 4, I need 2. How do I know this? From the balanced chemical equation, because in the balanced chemical equation, I have 4 in front of carbon. Chemical equation. So here's CO2, the relationship between CO2 and O2. Okay. So to get 4, I need how many O2 molecules or O2 moles? Based on the balanced chemical equation, to get 4, I need how many moles of O2? 7. We need 7, right? Okay. Therefore, to get 1, I need 7 divided by 4. Okay. And then, therefore, to get 50, I need 7 divided by 4 multiplied by 50. That should be it. Okay, so you plug and chuck these numbers to your calculator, and that will give you the answer. Can you confirm that that's the correct answer by entering the answer, whatever that is? Yeah. Okay. All right. Do we have any questions, concerns, comments about this? Okay, so calcium carbonate, you are heating that. When it is heated, you are getting calcium oxide and CO2. Okay, this seems balanced as it is. One calcium, one carbon, three oxygens. So it is balanced as it is when you write like that. Always so what we want to do is we want to identify what is given and what is being asked. Okay, what is given to you is the mass of calcium carbonate. Okay, and then what they're asking is the mass of calcium oxide. Okay, so you're going from mass of calcium carbonate to mass of calcium oxide. Okay, so here's what if you do not do anything else, this is what you need to do. Okay, so you need to write what is given. Okay, so you are given 10 to the power of 4 grams of calcium carbonate. Is everybody okay with 10 to the power of 4? Okay, I am given 10 kilograms. Okay, 10 kilograms in grams is, you need to multiply by 1,000. So I'm going to get 10,000. 10,000 grams is 10 to the power of 4 grams. This is what I wrote. Is everybody okay with that? Yes or no? I want an answer. Yes or no? Yes, thank you. Okay, all right. So so that is what is given to you. I wrote it in grams. That's all I did. Okay. Now, I don't want that. I want grams of calcium oxide, not grams of calcium carbonate. So I want to cancel it out. Okay. So only way to cancel it out is by dividing this by the grams of calcium carbonate. So this time, when you want to do that, what you do is you use the molar mass. Okay. So the molar mass of calcium carbonate is, calcium is 40. The relative atomic mass of calcium is 40. Carbon is 12. And oxygen is 16. You have 3 of them. 3 times 16 is 48. Right? 48, right? 48. So if we add them up, it adds up to 100, right? Right? 100 grams of calcium carbonate. Okay. So what I'm writing here is the molar mass of calcium carbonate. 1 mole of calcium carbonate, 100 grams of calcium carbonate is the mass of 1 mole of calcium carbonate. This is what I wrote. Okay. And why did I do that? So that I can cancel out the grams of calcium carbonate. Okay. Now I just have the moles of calcium carbonate at the. But I don't want that either. Okay. What I want is the mass of calcium oxide. Okay. So to do that, I need to switch to calcium oxide. What I do to do that is I want to convert moles of calcium carbonate to moles of calcium oxide. How do I do that? I go back to the balanced chemical equation. I see, let me use a different color. I see 1 in front of calcium oxide. Calcium carbonate, and 1 in front of calcium oxide. Therefore, the molar ratio or the stoichiometry between them is 1 to 1. Okay. So I'm going to write that here now. So I'm going to write moles of calcium carbonate in the denominator. So 1 mole, this moles. Okay. Here's the 1 mole. 1 mole of calcium carbonate in the denominator, because that is where where did this 1 come from? From the balanced chemical equation. Okay. And then in the numerator, I'm going to write this number over here, which is still 1. 1 mole of calcium oxide. Okay. And why did I do that again? So because I want to cancel out the moles of calcium carbonate. So we have moles of calcium carbonate here and the moles of calcium carbonate here. They cancel out. Now I am left with moles of calcium oxide, but I don't want that either. I want the mass of calcium oxide. So I want to cancel out the moles of calcium oxide. Okay. So to do that, I want to use the molar mass of calcium oxide. So I'm going to write in the denominator 1 mole of calcium oxide. Okay. And it has a mass of calcium is 40, oxygen is 16. 40 plus 16 is 56. So 1 mole of calcium oxide is 56 grams of calcium oxide. Okay. And when I do that, I can cancel out moles of calcium oxide. I am left with grams of calcium oxide. So now I take all the numbers in the numerator, which is 10 to the power of 4 and 1 and 1 and 56, and divide that by all the numbers in the denominator. 100 is 10 to the power of 2. Instead of writing, I'm going to write that. And then I have 1 and 1. That's it. Oh, this is good. This is good. Okay. So now I can do, I don't need the calculator right now. Okay. I think it's going to work out nicely. So it's going to give us the grams of calcium oxide. Okay. And that should be, this should cancel out with this. And then this should be 5,600 grams of calcium oxide without the calculator. And then if you convert that to kilograms, because they're asking for kilograms, you divide this by 1,000, and that will give us 5.6 kilograms of calcium oxide. Okay, that should be your answer. Okay, so again, this is telling you nitrogen is reacting with, let me write it, okay? Nitrogen gas is reacting with hydrogen. Oh, by the way, can somebody confirm that that was the correct answer for the previous question? Okay, perfect. Thank you. Okay. Right. Hydrogen. And then we have, it's going to produce NH3. We have 2 nitrogens on the reactant side. So I need to multiply my NH3 by 2 so that I have 2 nitrogens on the product side as well. Now I have 2 hydrogens on the reactant side, but 6 hydrogens on the product side. Therefore, I'm going to multiply my hydrogens by 3. That's it. That should be balanced now. Okay. So first of all, we wrote the balanced chemical equation. Okay. Second, we're going to figure out what they're asking us. All right. So they're asking about, so what is given is the mass of ammonia. Okay, this is what is given. Okay. Given. And then they are asking the grams of nitrogen. This is what they're asking. Okay. You might be asked different question in your based on the version you are getting. Maybe they're asking for hydrogen in some of your cases. Okay. So be careful there. Okay. Hydrogen has a different mass, a very different mass than nitrogen. Okay. So anyway, so we always start with what is given. Okay. So let's do that. Let's write that. Okay. In our algorithmic method. So we are given 119 grams of NH3. Okay. And they are asking the mass or the grams of nitrogen. That's what they're asking. Okay. So first thing we need to do is we need to get rid of the grams of NH3. Okay. To do that, what do? How do we get rid of the grams of NH3? Molar mass. Thank you. So nitrogen is 14, hydrogen is 1. You have 3 of them. The molar mass of ammonia or NH3 is 17. So if you divide this by 17 grams, okay, 17 grams of NH3, which is the mass of 1 mole of NH3. Okay, guess what? The grams of NH3 cancel out. Let me show you. So grams of NH3 cancel out with grams of NH3. And you're going to end up with moles of NH3. Okay. And then what we do is we do moles to moles. Okay. This is step number 1 in our process, converting grams to moles. Okay. And the second step is moles to moles. Okay. So what do I mean by moles to moles? You have an implied 1 here and then 2 in front of NH3. Okay. So we are going to be using this relationship, the relationship between nitrogen and NH3, because we want to go to nitrogen now, right? So we're going to write the moles of NH3, the number in front of NH3 in the denominator. Okay, so to get 2 moles of NH3, okay, we need 1 mole, this number over here, okay, we need 1 mole of nitrogen based on the balanced chemical equation, okay? And why did we write it like this? We want to get rid of moles of NH3. So to get rid of that, we need to write the moles of NH3 in the denominator, okay? And that's why we wrote it like that. So we can cancel out moles of NH3, okay? And then this is not enough either, right? They are asking for the mass of nitrogen, not the moles of nitrogen, because right now we are the moles of nitrogen. Therefore, we want to get rid of moles of nitrogen. So we know 1 mole of nitrogen has a mass of, what's the mass of 1 mole of nitrogen? That would be 1 atom of nitrogen. Yeah, so because you have two atoms of nitrogen in N2, so the mass of 1 mole of nitrogen should be 28 grams. Okay, 28 grams. 2 times 14. Okay, if you do that, you see that we are canceling out the moles of nitrogen and ending up with grams of nitrogen. And then if you write the numbers in the numerator now, we have 119 and 1 and 1 and 28. I have a dot here in front of them. Okay, if you don't like the dot, you can write the cross to indicate multiplication. I mean the same thing. Okay, and then divide this by 17 and 2 and 1. Okay, can somebody tell me what you get if you do this? 98. Okay, so you get 98 grams as your answer. That should be the mass of nitrogen we need to get 119 grams of ammonia. So one other thing, yes, sir. You got hydrogen in your version, okay? So let's do hydrogen as well really quickly if we can do it. Okay, so if your version is about nitrogen, this is your answer, okay? And if it is about hydrogen, the place, what is changing here is instead of in 2 here, we are dealing with, let me do that here in a different color, okay? Nitrogen will be replaced by hydrogen over here, okay? In the balanced chemical equation, to get 2 moles of NH3, we need 3 moles of hydrogen. Therefore, this should be 3, okay? And also, the mass of 1 mole of hydrogen is not 28 grams. It is 2 grams. Okay, so we need to write 2 instead of 28. So if we do that, let me see how I can do it. Okay, 2 grams over there of hydrogen. So 1 mole of hydrogen is 2 grams. So this is what you need to do. Okay, and then how does it change here? So we still have all the same numbers, but instead of 28, okay, we have 2. And this is 2. And then instead of 1 here, okay, we have 3. So this should be a 3. And then in the denominator, we have 17 still and 2. And then denominator is the same thing. Okay, only thing that changed here is the 2 and 3. That's it. Okay, this number over here. What did you get there? 21. Okay, so you got 21 grams of hydrogen. So that's for the hydrogen version B. Again, what we're doing here is hydrogen reacting with oxygen. Okay, when you do that, you're going to get water. Basically, you're burning hydrogen. Okay, so if you burn hydrogen, you're going to get this. Hydrogens are balanced on both sides, but oxygens, you need only half of this, right? So for oxygens, you need only half of this. So this should be the balanced chemical equation. But because we don't like fractions, we multiply everything by 2. So this is canceling out. This is 2. So it's 2, 1, 2. 2 hydrogens, 1 oxygen, and 2 H2O. You should balance this though. Okay. So starting with what is given. Okay. And then the goal is to end up with what they're asking. That's it. Okay. So, make the path to get to what they're asking. That's all you're doing here in your head. Okay. All right. So once again, let's do this. Okay. So first of all, we need the balanced chemical equation. Here it is. We did that. Okay. And then we need to figure out what is given and what is asked. So I see a number here, 90 grams of water. Okay. That seems to be what is given. This is given. And then they are asking the moles of hydrogen. So, okay, this is dialing down actually, not the mass, the moles of hydrogen here. Okay. So this is what is being asked. Okay. So let's do that. So we'll start with what is given. We have 90 grams of water of H2O, right? But we don't want the grams of H2O. So we want to get rid of that. To get rid of the grams of H2O, we're going to divide by the molar mass of H2O. So in other words, we're going to divide this by 18 grams of water, because that's how many grams of water we have in 1 mole of water. Okay, that's our step 1. Okay, converting grams to moles, because you know that when we do that, grams cancel out, we're going to end up with moles. Okay, and then the next step, we want to convert moles to moles. I think we're done actually, because they're asking only for the moles. Okay, so to do that, to convert moles to moles, we need to go to the balanced chemical equation. They ask him for hydrogen. So to get 2 moles of H2O, we need 2 moles of hydrogen. Okay, so we're going to write that exactly. Okay, so but we're going to write the moles of H2O in the denominator. Okay, so 2 moles of H2O in the denominator. Why did we do that? Because we intend to cancel out the moles of H2O. And then in the numerator, we are going to write the moles of hydrogen, this number over here. Okay, so 2 moles of hydrogen. Okay, to get 2 moles of H2O, we need 2 moles of hydrogen. That's what it means. Okay, now if we do this, we're going to end up with moles of hydrogen. That's it. And then this should be, let's see if we can do this right away. I mean, let's write this anyway. Okay, so we have in the numerator, we have 90, and then we have 1, and we have 2, and then in the denominator, we have 18, and then we have 2. Okay, so let's cancel things out. Okay, 2 cancels out, and then 18, we have 5 18s in 18s in 90, I believe. Is that right? So therefore, it should be 5. I didn't think much, but I think this should be the answer. Moles of hydrogen. Is that right? Is that the correct answer? Yeah? Can somebody confirm, please? Okay, perfect. Thank you. All right, some of you might have oxygen here. I mean, if you see the pattern, I mean, with the version A and B, the difference is in one case you have one reactant, the other version you have the other reactant. Any questions about this or anything? Do you have oxygen or hydrogen, sir? Is that the correct answer? Okay, perfect. It's the same. Okay, let me see. So we have H2S. I need a thicker pen. Give me a second. So this, okay. So H2S is reacting with oxygen. I think we did the same. We balanced the same equation like, on Monday as well. And it gives us sulfur dioxide, SO2, and H2O. H2O. So maybe this will ring a bell. So hydrogen, we have 2 on the reactant side. We have 2 on the product side. I'm not going to touch it. Sulfur, we have 1 on the reactant side, 1 on the product side. I'm not going to touch that either. Oxygen, I have 2 on the reactant side, but 3 on the product side. So we have a problem there. Okay, so what do? I want to have 3 oxygen atoms on the reactant side as well. So to do that, I'm going to multiply the number of oxygen molecules by 3, but that will give me 6 oxygen atoms. Therefore, I'm going to divide this by 2 again, so that I will have 3 oxygen atoms on the on the reactant side. So this is Unit 4 module 1 is mainly like balancing. You will see a lot of balancing there actually, okay, like this. Okay, anyway, we don't want to have fractions in our balanced chemical equation, so I want to get rid of that. To do that, I'm going to multiply everything by the denominator, which is 2. So if I do that, this 2 cancels out. We're going to have a 2 here, and then we're going to have a 2 here. This should be the balanced chemical reaction. Okay, that's number 1. And then we need to figure out what is given and what they're asking. Okay, so let me switch to blue. They're asking hydrogen sulfide reacts that blah, blah, blah. How many grams of SO2 will be required to, how many grams of SO2 will be produced if 100 grams of H2S reacts with 100 grams of oxygen? Okay, so when you tackle, let's make this the last question from Unit 4 Module 2. So when you tackle this problem, the first thing is to determine the limiting reactant. Okay, I feel like I should switch to my notebook, but I'm going to try to do this here because it's easier to see now. So now, based on the balanced chemical reaction, this is what I'm going to write. H2S and O2. Okay, so based on the balanced chemical reaction, to react with 2 moles of H2S, okay, I'm going to need 3 moles of oxygen. Okay, so this is what is balanced chemical reaction tells us. Okay, but now what I want to do is I want to know how many H2S moles we have and how many oxygen moles we have. Okay, how do I do that? Here's the grams of H2S. If you use this equation, mass divided by the molar mass, okay, and that will give you the moles of H2S. So let's do that. So we have 100 grams is our mass, and the molar mass of H2S. What's the molar mass of H2S? 34. Thank you. Sulfur is 32. Hydrogen is 1. We have 2 of them. Therefore, the molar mass is 34 grams per mole. Okay. So if you do that, you're going to get the moles of H2S, which is, can somebody give me the answer? 2.93. Yeah, it sounds okay to me. 2.93 moles. Okay. And then oxygen. Okay, we do the same thing to oxygen as well. All right. So if we do number of moles of oxygen is, mass is 100 grams. Okay. Divide that by the molar mass of oxygen, which is 32 grams per mole. Okay. They're very similar actually. Grams per mole. And that will give you the moles of oxygen. What's the moles of oxygen you got? 3.125. 12. Okay. 125 or 13. Okay, let's say 13. 13 moles. Okay, this is what we have. Okay, so now what we want to do is we want to determine which one is limiting the reaction. Okay, so here's how we do it. Okay, so we can pick any one of them. We can pick H2S or O2. Okay, so to react with 2 H2S molecules, so H2S moles, I need 3 moles of O2. How do I know this? From the balanced chemical reaction. So here's 2, here's 3. To react with 2, I need 3 oxygens. Okay. To react with 1, I need 3/2 oxygen moles. Okay. But to react with 2.93, okay, I need 3/2 multiplied by 2.93. What do you get here? How many moles is that? I don't like playing with decimal places that much, but this question calls for it. Come there again. I didn't hear you. 6 point. Okay. So it should be less than 6, right? Yeah. How much is it? 5.395? 4 point. Okay. 4.395. Okay, let's write it here. 4.395 of 395 or 396. 395. Let's go with this. 4.4. Okay. Anyway, so here's the point though. We need this much. This is what we need. Okay. But what we have is only 3.13 is what we have. We have less than what we need. Okay. Therefore, oxygen is limiting our reaction. Okay. So oxygen is the limiting reactant. So this is what we determine. So this guy is limiting. That's the most important thing. Okay. Do we have any questions about determining the limiting reactant if you are given the numbers like this? In Unit 4, Module 1, okay, what we did was we were given the submicroscopic representation to do this. But here, we are given the mass, and then based on the mass, we have to determine the limiting reactant, and this is how. You know what? I'll do both. It's fine. All right. Now here's the thing. I'll do the thinking method first. Okay. So they're asking about SO2 now, right? In this case, so let me use a different color. Okay. I'm gonna use let me see. Okay, brown or maybe brown. Okay. Anyway, so oxygen is the limiting reactant. And SO2 is what they're asking. Based on the balanced chemical reaction, if we have 3 moles of oxygen, how many moles of SO2 will we get? Everybody, okay? If we have 3 moles of oxygen, how many moles of SO2 will we get? 2, right? So it's from the balanced chemical reaction. With 3, we're going to get 2. Okay? Now we have, okay, so that means with 1, we are going to get 2/3. Okay, but we have 3.13 now. Here's the moles of oxygen. Okay, therefore with 3.13, okay, we are going to get 2/3 multiplied by 3.13 moles of SO2. Okay, it's going to be the moles of SO2 we are going to get. Okay, now we do not, so we need the mass of SO2. So to convert moles to mass, what we need to do is we need to multiply this by the molar mass. Okay, so SO2 sulfur is 32, and then oxygen is 16. You have 2 of them, therefore that is 32 as well. So it should be 64. 64 grams per mole. Okay, so moles cancel out. You're going to get the answer in grams. That should be answer. Can somebody tell me the answer for this? I want to show you something else here. What did you? 33 seems to be fine. Okay, 133. Okay, 133 grams. Let's say 133 grams. You actually, okay? So I want to get rid of this for the moment. Okay, so we know the limiting reactant is oxygen now, right? So here's what I'm going to do again, okay? So what is given is the grams of oxygen. So I'm going to start with that. We are given 100 grams of O2, okay? We're going to end up with grams of SO2. This is what they're asking, okay? So I want to do this algorithmic method now. So what I'm going to do is I'm going to get rid of grams of oxygen by dividing this by 32 grams of oxygen. Why did I do that? Because that's how many grams of oxygen we have in 1 mole of oxygen. Okay. And then, oh, I need the balanced chemical equation. Let me see. Oh, shoot. Okay. So in the balanced chemical equation, we have We have H2S reacting with oxygen and giving us SO2 and H2O. Okay, so there we had 2, 3, 2, and 2. Okay, so now I want to convert moles to moles. Okay, so with 3 moles of oxygen, let me have a different color. With 3 moles of oxygen, I am going to get 2 moles of SO2. Okay, so I'm going to write 3 moles of oxygen in the denominator. With 3 moles of oxygen, I am getting 2 moles of SO2. Something happened, I don't know what. Anyway, so how do I get this from this number over here from the balanced chemical equation? Okay, and then that's not going to be enough. I need to go to the grams of SO2. So I need to get rid of the SO2 moles. So 1 mole of SO2, okay, has a mass of 64 grams. Okay, it has 64 grams of SO2. Okay, if you do this, you see that, let me see if I can, something happened here. Let me go to the question again. Here we go. I think this is the one. Okay. So if you do this calculation, you see that the grams of oxygen cancels out, moles of oxygen cancels out, moles of SO2 cancels out. You're going to end up with grams of SO2. Can somebody tell me what you get here? If you do this calculation. Yeah, same number, right? Yeah, 133 grams of SO2. This is the other way of doing the same calculation. Okay, you determine the limiting reactant, and then you go from the limiting reactant to what they're asking by setting this up like this. All right. So if you have, so I think Aaron and then another gentleman over here. What's your name, sir? Can you had H2O, right? So only difference between H2O is this. Okay. So let me show it to you in different way now. Okay. So if you had H2O instead of SO2, what you do is this. Okay. Instead of writing SO2, you need H2O here. Okay. So this should be H2O. Okay. And then from the balanced chemical reaction, you see that the relationship between oxygen and H2O is still 3 to 2. So this is still fine. This is still 2. Okay, from the balanced chemical equation. But the difference is you have 1 mole of H2O is not 64 grams of H2O. Okay, what is it? 1 mole of H2O is, thank you, I heard that, 18 grams. It should be 18 grams. So Aaron, that was the issue, yeah? It's just the mass of H2O. Aaron? Yeah? Yeah, you need to switch that. Okay. Do we have any other questions, concerns, comments about this? Okay. So by the way, this is the most complicated version of the questions you can get. Okay. So combustion, this means reacting with oxygen will produce CO2 and H2O. Okay. Then we need to balance this. Okay, we have 5 carbons on the reactant side, so we need 5 carbon dioxide. We have 12 hydrogens on the reactant side, so therefore we need 6 H2O. Now we have 2 oxygens on the reactant side, but on the product side we have 5 times 2, 10 plus 6, 16 oxygens. Therefore I need to multiply this by 8. Do it, okay? To get, so they're asking the relationship between H2O and oxygen. Okay. To get 6, we need 8. To get 1, we need 8 divided by 6. To get 12, we need 8 divided by 6 multiplied by 12, which is 16, right? Is it 16? Yeah, 16.